Today we're going to start talking about linear equations in two variables. So we'll start with just the basic form of what this equation looks like. And we describe it as an equation that has an x and a y, and that those x and y's can have numbers on the front, a, b, and c are all real numbers. Okay, so they can be decimals, they can be fractions, they can be rational or irrational numbers, they can be positive or negative, but there's an a b, and a c that are real numbers. The x and the y are going to be our two variables, and at least one of a or b is not 0. Okay, so a could be 0, which means the x term would disappear, but if that were the case, b could not be 0, or vice versa. B could be 0, making the b term disappear, but in that case the a could not be 0. And we'll be looking at some more examples of these as we go through the following lessons. So that's one way that we can express a linear equation in two variables, is by writing an actual mathematical equation for it. The way that we look at the answers to these equations are in one of the following three forms. You might remember from our unit on inequalities that we used this part of the graph, just the x part, to graph solutions for inequalities, because those solutions had more than one answer. X could be 6, but it could also be anything smaller than 6, or x could be 2.5 or anything bigger than that. So we needed a way to show that it was lots of different answers. Well, these linear equations are also going to have an infinite number of answers, and those answers are going to be points that fall along a line. And so they'll have an x amount. If we wanted to look at, say, that point right there, it would have an x value, and it will also have a y value. So if this particular number line was counting by ones, then you'd go 3 out on the x, and it looks like 1, 2, 3, 4, 5 up on the y in order to get to that particular answer. So the way that we would record that answer, since our answer is now more than just a single digit, we would write it as an ordered pair, with the 3, the value that we used to get our x, coming first, and the 5, the value that we used to find our y, coming second. And these ordered pairs have a way that we can organize them in a table of values. So what we do is start with an equation where we've been given either the x or the y. We substitute that value in and we solve it to get the other one. So we might have an ordered pair in this case where we put 3 in to our equation, and when we solved it, we ended up finding out that y was equal to 5. So that particular solution to this linear equation can either be described in a table of values like this, or on a Cartesian coordinate system by putting in a point and on a line, or as an ordered pair, like 3, 5. And we'll be seeing lots of examples of these different ways of looking at linear relationships into variables as we go through this unit. So the first thing that we're going to do is something that looks very similar to the way that you checked your answers to problems back in the linear equations in one variable. So there they said, they gave you an equation that only had one letter in it, had just x's in it, and they said evaluate this, or determine if x equals 2 is a solution. Well, this is the same kind of situation, except now we're given both an x and a y that we need to substitute into our equation. So looking at this equation above, 3 plus 4 equals a negative 2. I'm going to put in the value 2 in place of my x, and the value negative 2 in place of my y. And then I'll just follow order of operations here on the left side, solve this expression, and see if it does in fact end up equaling -2. If it does, that means that this ordered pair is a solution to this equation. If it doesn't, then it's not a solution. So 3 times 2 gives me 6. This is a -8, and 6 plus -8 is a -2. So yes, 2, -2 is a solution. The next pair that I'm going to check is the pair 1 and 5/4. So again, the 1 will go in place of the x, and the 5/4 in place of the y. And I'll put the rest of the equation around this. So it's 3 times 1 plus 4 times 5/4 is supposed to equal a -2. Well, 3 times 1 is 3, and 4 times 5/4 is 5, and 3 plus 5 is 8. So in this case, these two numbers did not turn out to be equal. So the ordered pair 1, 5/4 is not a solution. The other type of question you'll be asked to do in this section is to complete an ordered pair. So again, the first digit that they're giving us, this one that comes first, is always representing the x, and the second one the y. So in this case, they're telling us only what value to substitute in for x. Then we'll solve that expression, or solve that equation, to determine what the value of y is. So I have y equals 4 minus 5. I'm going to put a 1 in place of my x. So I get y equals 4 minus 5, which is y equals a -1. So to complete the ordered pair, I would write my final answer 1, because that was the value of x that we put into the equation. And when we did that, the solution came out -1. So I would express my answer as the ordered pair 1, -1.